Oh, welcome everybody. It's January 18th, 1 p.m. Pacific. We're in the Propeller live forum and a lot of people online today. So let's go over our topics because we have some schedules to think about. Before we do that, just some brief house cleaning things that are going on at Parallax relative to the Propeller 2. We got 3 new quick bites being posted right now from Stephanie. They're in the works. The first one is for the GPS unit that we have. So that's more or less just a driver. That's our part number 28054. The second one is for the real-time clock module we came out with before Christmas, part number 28054. And then the third one is, I'm sorry, the second one is part number 64013. And then we have some Johnny Mac code with a one-wire driver for the DS18B20 temperature sensor. So those 3 are going up, and I'll send y'all a message when they're posted. It's probably later this week. So 3 new. And I think we're all aware that one of our important contributors in the Parallax community passed away last Friday. That's Phil Pilgrim. And I don't know who all met him, but I had a chance to meet him in person many times over the past 25 years. And we did lots of productive work together, including the Scribbler robot. And he did the GUI for the original Scribbler and did all the source code and testing of that hardware. And he also made some motherboards out of the basic stamp for us and did the color sensors and a whole variety of other stuff. And if you had a chance to know him, he was a super gentle person. He can be kind of sharp on the forums, but he always had good advice and lived a really tidy, fun life in this little community of Port Townsend, Washington. So we'll miss him, and we'll be thinking of him often. So Godspeed to Phil. Today, 3 things. So first we're gonna have Jeff start off and show the Propeller Tool 2.9.2 improvements, which include debug. And he has to be out here at 2:30, so we'll 1:30, I think he said. I'm not sure, but we'll move to Jeff first.
2:30.
Oh, okay.
Yeah, got time.
Yeah, and we're in the same time zone. Good. And then Brian Holdsworth will share his Linux efforts on the P2. And I don't know how much we'll know about this, but I'm just coming up to speed on it, so I'm learning today as well. And then Stephen will loop in and show the P1 to P2 behaviors in VS Code. So anyone who has any comments on that, this is a good day to share them. So it's kind of a tool day. And then Chip is hanging out, and any questions you all have or topics, is there anything else you want to share? Anyone who's online that I can put into the queue here? Okay, well, just message me if anything comes up, and why don't we just get rolling, Jeff?
Okay.
I can stop the share and you can have at it.
All right, I'll share my screen. Okay, so I'm going to show just a few things of from the latest release of the Propeller tool. There's been a few changes, well, a couple of beta releases that maybe you've played with, maybe you haven't. So some of this might be new to you or might be a little bit familiar. But mainly I'm going to focus on the very latest version, which brings it up to speed with Peanut version 37. To start off with, something that I know a lot of people have been wanting is if you start a new project with one of these templates, it used to be that it wouldn't know that, like, for example, if I selected the new from P2 template, it loads it up, but it wouldn't know that it was actually P2 code. So if you tried to compile it, it wouldn't compile. You'd have to save it first as spin2 code. So that's been fixed as soon as I don't know if you noticed, but as soon as I open this up, it recognizes it here. You can see in the tab, it says P2. And if I go change something and go to save it, it automatically selects the P2 the spin2 source extension. And of course it compiles as P2. And the same thing happens for the Propeller 1 template, it recognizes it as Propeller 1 code, or it knows that that's what the intention is here, and compiling or saving automatically selects the spin 1 mode. That was a bit of an oversight in previous versions, and it was surprisingly hard to solve. One of those crazy things. So let's see, the next thing I wanted to show is, oh, my notes got obscured here. There's a new feature in the P2 compiler that allows you to influence the values of constants in a child object. So what I'm going to show here is a simple little child object where I have this multiplier constant and a count constant that get manipulated here, multiplied together, and displayed on the screen in a little loop. If I run this from a parent, so here's a parent object that is referencing the child, and then just calls run. You can see down here in the debug, I get what I expect, just one iteration of the loop in this case, since the count was set to 1 and the multiplier was set to 2. So 1 times 2 is 2. However, if I do something like this, where in that same reference, I follow it with this pipe symbol and the constants in a comma delimited list of what I want to modify. So I said, let's set multiplier to 3 and count to 5 and run this. Now you get different behavior here. So now there's 5 iterations of the loop. And of course, the multiplier that it's using is obviously different here. I could show you again. I'll make it iterate 10 times, for example. So unlike before, where you could only manipulate things within an object via parameters and methods that you're calling, now you can actually change constants as well. Which might be really good for things like maybe an object was creating its own buffer of a certain size and you want something a little bit bigger. You can try modifying, without modifying the child code, you can influence it from this top level. And also I'll show you some changes that happened on the info view. So if you go compile view info, or you just press F8. This for the P2 was not showing the proper values for the clock settings. And I think some of these numbers were messed up as well. And I believe also the data that was shown here, so it was kind of useless. Now that's been fixed. So you can see the organization of everything. And it actually calls out the spin interpreter. I'm just scrolling with the mouse wheel right now. So you can see where the spin interpreter is. You can actually, see the actual mnemonic or the binary values that relate to it. And either any of these things here, these little labels on the legend, or these little color boxes, are clickable to navigate to that section. So I just clicked on debugger, which shows me where the memory is reserved at the end of memory for the debugger engine, which is right here. If I went back and turned debugging off, for example, and go back to the memory screen, now that doesn't exist. You see it's not there in the image, and the end of memory is fully available to your user code. Okay, I'm going to turn that back on.
Hey, Jeff.
Yes.
Have you solved the problem with the multiple, well, like different instantiations of the same child with different parameters?
No, I haven't. What Chip is talking about is when I created this version, actually when I was making the little video showing what's changed, I noticed that if you create 2 instances of this same object, like this, you wouldn't get the results you expected, where this first instance was where the constants were changed, and the second one was the way it was as written in the code. Chip and I have looked into this since then and determined what it was, or what the cause was. I don't know, have you changed it in Peanut yet?
No, I almost did last night, but I didn't get into it. But the problem was that it compiles the child object and makes an OBJ file, but it doesn't differentiate the OBJ files for differently parameterized instances and arrays of instances. So the last OBJ file written by that name becomes the one that gets pulled up later in compilation. So in this case, it would, the first settings would be gone, and then the default settings from the child, because that would be the last one compiled, would exist in both child 1 and child 2. But this is not complex to fix. We just have to like enumerate some files and then delete, you know, so they're unique during compilation and then erase them after compilation. So if you're just doing like one instance, even if it's an array, but one modification of an object with parameters, it will it'll work right. But at the moment, if you want to do the same object but with 2 different parameters, rename the original object file for the second case. Like make what, like put something there, Jeff, like, yeah, right. Do something like that. Just copy child to child 2, and then it will still be differentiated during compilation. But right now it's getting munched because it's kind of like it's only seeing the last one it compiled because there's no name difference.
Chip?
Yes, yes.
Yeah.
So even when that's fixed, it's the behavior, if you're using parameters with the objects, is that they're behaving like they were completely different objects anyway. So I see an occasional use for this, but it seems that from a memory standpoint, it might be more efficient just to pass multiplier and count as parameters, save them as globals in your object so that you don't have duplications of your object code.
No, absolutely. I mean, that's the most flexibility, but the problem comes in when you're trying to do things like declare memory buffers.
Yeah, right.
It has to be done at compile time. So,
yeah,
you know, that's where this really is important.
Right.
Yeah,
Or cases where the object, the child object you're using wasn't written by you and you really don't want to go modifying it for whatever reason.
oh, right, sure.
This might be a quick way to get what you want and move on.
Yeah, for objects with buffers, I've been declaring them in my parent object and passing a
Yeah.
size to them. It's a little bit unwieldy at times, but that seems to be the best way to mitigate memory issues. And then I have access from the parent to the buffer manually. Jeff and I were talking about this a couple of weeks ago. So when I was doing some testing, I wrote a P1 next-gen object for a new product, and it was convenient to have the serial buffer for the next-gen actually all the way up in my test parent, so I could see the raw values coming back from the next-gen and made sure I was processing them correctly.
Yeah, that's, I mean, you can always do things like that, but in case you have, like, to make an object, let's say you have an object that's going to work on some pins. It is, you know, tedious to write the code to make it flexible for any pin. So for a really like industrial hardened object, you want it to be able to be completely configurable. But if you're just doing something quick, there's facility in just being able to say, just use these hard pins. Then you get to hard code those pins in PASM and other places. And it gets you around having to, like, you know, make variables to point to pins and do this kind of stuff.
Yep.
Yeah, so we'll fix that. So I think in most of the cases, people aren't using multiple instances of the same object. But we will fix it because it certainly wasn't intended to work the way it is currently.
Yeah,
we'll get that fixed.
Speaking of bugs, apparently there's an issue where if you're compiling P1 code, it doesn't respect the underscore stack and underscore free symbols anymore with the new prop tool.
What is it again? The underscore
stack and underscore free. It doesn't seem to check them anymore.
Oh, you know, gosh, I wonder if my compiler, I haven't thought about that.
Only in the P1 compiler. I don't think the P2 compiler even supports it at all. Like just open one from the template and create an array that's really big, I guess. Yeah, that's bound to be enough. Then set 3 to like 8,000 or something. And
Yeah,
it will probably.
yeah, I
load.
think looks like I don't have that in the P2 compiler, like you said.
What were you?
No, if it's 8,000, it won't compile at all, but maybe check that first if that even works.
Oh, well, it won't work because I've got this object here. Get rid of this. Oops. Okay, yeah, that compiles. And then you said
If underscore free constant, set it to like 8,000 maybe.
yeah, that compiled.
And it shouldn't, because that totals to 9,000 longs, and that's bad. You can see there's not 8,000 free longs, but it compiles anyways because
Oh,
it feels like it.
wow. Okay, so maybe the expression that I'm using to check things isn't quite right. All right, I'll note that one and take a look at that.
Good catch.
Yeah, thanks. Okay, so let's see, where was I? I think I was about to show, here's just another example to show with the memory view open, because this is one thing that you couldn't do before in the P2 mode because of the way that the info screen was messed up. So here's an example where there's just some data defined, and you wouldn't be able to find it in the code, I believe. And now you can see it right here. So here's this first long value AABBCCDD in Little Indian format, followed by the second and the third. That was one of the first things I went looking for. And I think what made somebody realize that, hey, it's not showing the right code. So that's been fixed.
Yeah, that's good.
Oh yeah, and now that the binary info thing works, can you actually use it to load a binary that you've just compiled to a file somewhere? That's
coming. That was one of the final pieces. I just didn't have time to fix that for P2. So this is you're talking about these. I'm sorry, these buttons here. Load
yeah, exactly.
Flash. Yeah.
Well, it's a save binary file, and then you drag it onto the window. That sort of thing. Yeah.
So if you load a binary and then try to download it, I believe it tries to download it as a P1 code because it doesn't realize that it's P2.
I guess you can't really tell the difference, right? I guess
that's one of the reasons.
Use some sort of heuristic to determine it from the beginning, because P1 binary usually begins with the 80,000 as a clock frequency. Yeah. But usually it doesn't actually mean anything. I guess correct thing to check would be the spin header, because that is always there. But how do you verify that it's actually a correct spin header and not just bullshit?
Those are the same kind of conundrums I ran into and realized, okay, this can be harder than I thought. But it is possible, I believe. Okay, so let's see, next step here, I'm gonna stretch this out here so you can see a little bit more. We're gonna talk about the debugger. So in Peanut version, I don't remember if it was version 36, I think it was 36, that introduced the PASM level debugger, which is where you get this little screen when you download. So this is showing the low-level code. The actual, you can see it here. So here's a couple of encode instructions and a subtract and an add. You can see it right here sitting in the register memory. And you can single step through this now. So this is PASM level debugging. in Propeller tool, just like you can do in Peanut for the last couple of versions. Up here, by the way, is the free running counter. So that's running, you know, constantly all the time. It never stops unless you power down, of course, or reset. One thing I wanted to show here is if you end up in a spot where, like this instruction here, jump is about to jump to the same address that it's currently sitting at. Originally, as you click this button, can everybody see that this button is flashing? Okay.
Yeah.
Every one of those flashes is me clicking on the go button. You can see nothing seems to be happening, and that's because the program counter is not changing. The code
Did I
jumps
make
back to
that thing
itself.
flash maybe?
I think it would be nice if it flashed this line.
Yeah,
Also.
we made the button flash. That was like a concession to the whole problem that it didn't seem to be doing anything. So we
Yeah,
made the go button flash, but it might be good if that, the trouble is the big white line doesn't normally flash as it steps anyway, but we could just have it go through some cycle where it turns off and on again.
Yeah, just like some little flicker to give you some instant feedback that something's happening. The button flashing makes a really a good impact. I mean, when I ran this code the first time and got to this point and just kept clicking, I thought the whole thing was frozen. Even though I could see that this thing was constantly moving up here, I felt like the interface wasn't responding to me, but it actually was. Let's see, I can't remember if I wanted to show anything else in this code. I don't think so. I'm going to reload this here to show you that you can single step with just a left click of the button, or I think you can press the enter key too, right? Oh, enter key runs.
Yeah.
So here, I'm re-downloading again. You could also left click to single step, and if you right click on the go button, it'll step as fast as it can through the code, and update your display on your PC as fast as
Hey
you
Jeff,
can.
it could go like 100 times faster than that, but I slowed it down so that you can watch it do something. Otherwise, it just it doesn't mean anything, just flitting all over the place.
Well, good. Okay, so not as fast as it can, but in a practically fast way. So you can kind of watch what it's doing. Yeah, human fast. Okay. And let's see. So here's another example. This example comes right from the documentation that Chip wrote. Kind of the same thing where we start. Well, actually, the previous code was just PASM only code. This one has some spin code in it here that you see is going to eventually launch a little PASM piece of code into another cog, and then it's going to sit here and repeat in a little loop, incrementing a variable. So what you're seeing on the screen here right now is actually the interpreter, the spin2 interpreter that I'm.
Just one thing.
What is that, my dear?
That I'm stepping through. I'm going to right click on it so you can see eventually here it'll get to where it's launching the cog. There it goes. So now I've got two cogs running. This one's running the interpreter, and the cog one here is sitting there waiting for me to do something, but it's basically paused on that assembly code, that PASM code, these little add instructions, and I can sit here and step through this, and you can see how it's affecting registers here, or make it run.
So Peanut opens one window per cog?
Mm-hmm.
Yes,
Yeah.
or Propeller tool.
Yeah, so you can debug all cogs, all 8 cogs simultaneously. It's all kind of, each one has a separate communication relationship with the PC software. So, and they don't know that the other guys are doing the same thing, but they can multiplex memory and whatnot so that they share like the serial pin resources and the cog save, memory save resource in the that protected 16 KB at the top of memory.
Where do debug statements themselves, where you've typed in something that you want to display, does that show up on that window or not? Or does that just come out on that debug output only?
Well, what he did here is he defined this debug main symbol, which means
Yeah,
the first thing you do is open the debugger and let the user see what's happening. So he didn't have to insert a breakpoint anywhere. But if you put just a debug without any parentheses, just a straight debug in either PASM code or spin code, it will create a breakpoint at that point. And what that resolves to in PASM is a break #0. And the same thing in spin. It's like a 3-byte deal.
Yeah, so I'll show an example of that. So in this case, like Chip was saying, that was everything that you saw happen when we downloaded was launched or started because of this constant that was defined, debug main.
Yeah, meaning break on all main code.
Yeah. But here's a little example, very simple, short little piece of code that's just spin code. I wanted to show that you could also use this debugging interface for, to kind of see what's going on inside your spin code. It does show it at just the PASM level, but you could still utilize it in this way that Chip was mentioning. So if I just run this as is, you'll see that it's incrementing this counter quite fast. And maybe in this little loop here, there's, probably, there could be lots of code in here, but you might realize, hey, something strange is happening in this code. And I've thrown this debug in, maybe it's scrolling by too fast. I still can't see exactly what's going on. So you could simply just type this, a debug without parentheses. It's important to not have parentheses. This is effectively a break instruction, like Chip said. Now when I run this, we're up. Again, this is the spin interpreter that's shown over here on the left side. But down here, this is the screen that quickly scrolled by, but now it's just sitting here waiting for me because it ran through all of this code and now it's sitting on this debug command waiting for me to click go. So every time I click the go button, you can see every iteration of the loop in this.
okay. Yeah, that's what I was asking about then, whether you could do that. Thank you.
Mm-hmm. Yeah, and of course, I'm showing this with a debug statement, printing something to the screen just so it's pretty easy for everybody to see on the presentation. But you could, of course, throw these little debugs without parentheses, scatter them throughout your code for anything that maybe isn't spitting debug data back to the PC, but is controlling some motors or flashing LEDs or something. And you'd be able to kind of, step through every little breakpoint that you've created at these debug statements here. Does that make sense to everybody?
Makes sense to me.
Okay.
Yeah, I guess you can't hear me nodding, huh?
Oh.
We
Yeah,
need
so
to be
it's
in the metaverse.
in the metaverse, right? Yeah, so that's what I wanted to show today, that now you have another layer of debugging capability in Propeller tool that you hadn't had before these recent versions.
Thank you very much.
You're welcome.
That was a good way to demonstrate how to break. Just put another debug after your spin code, and that'll put the brakes on it, and then it automatically goes into the debugger in debug mode. So
Yeah, I didn't know you could do that.
Yeah, so you see the little button there that says debug and it's lit up. That says that it's going to break. Not if you hit main, it would single step, but if you leave it on debug, what it's going to do is going to run to the next debug or the next break instruction.
Yeah, so it's because of the way it's set. When I click go, it's actually running full speed, right, Chip, until it gets to the next debug
And then it
statement.
halts again.
If I click on main here and click go, you'll see it stepping through code in the spin interpreter, and I could right click on it to have it run, which of course will take a very long time to wrap around.
Okay,
And
now
I think in Yes, go ahead.
Click on debug right now, just without hitting anything else. Just hit debug, and then it continues running, but now it's with a different trigger event. Sorry, Jeff.
Yeah. No, that's fine. I actually hadn't tried that, so I didn't know it did that.
Yeah, you can just dynamically switch the, what causes it to break.
Yeah. One thing to note also, though, in this main mode is it actually ignores debug statements. Is that correct?
Oh, yeah, that's true, because it can't differentiate. I should have added like one more status bit into the whole debug logic, and I could have told the difference, but
Yeah,
no.
So for a little bit here, it's been showing us it's stepping through the spin2 interpreter. If I stop this right now, switch over here and click go. Yeah, you see down here, it didn't.
Yeah, now it's going to work again.
Yeah, it didn't show. You can see where it skipped. It was at 114, 115, and then the next one was 132.
Yeah.
Right in here is where I was running it with that main, you call that a trigger?
Yeah, well, the main code means every single instruction. It's not an interrupt instruction.
Okay. I see. And so all of the rest of these are interrupt instructions. Well, except for.
Yeah, so init means
kind of a
on
special
cog init, like run until you hit a cog init. And you can put these buttons and these conditions in combination. And then break. Gosh, what's the difference between break and the address breakpoint? I can't remember. Anyway, but you have lots of interrupt. You can go on break when you're going into an interrupt or when you're executing an interrupt instruction. That's why you have two separate int3, int1, and 2 buttons.
Okay. And by the way, here, a left click on these items selects them. And if you want to toggle it off or right click on it, we'll toggle that off.
Yeah.
I guess it always has to have something.
Break is the asynchronous break where you have to have another cog able to serve the other guy's asynchronous break signal. So break is allowing like asynchronous break, which you have to have another cog in debug to make happen.
So like
Interrupts another cog.
Like in this example where we have two cogs running eventually. There we go.
Yeah, do you have two there? Yeah, so there you go. So yeah, hit just break on that guy. Okay, now he's running full speed. Now hit the brake button. Boom, that's where he's at.
All right.
You can, and then hit
And
go.
that's only possible with another cog that's currently exercising its debug routine.
Yeah, because the PC will tell it when it does the breakpoint that, hey, create an asynchronous breakpoint for this other cog. But you have to have some other cog ready to take the command and do it, because the one that's waiting for the asynchronous break is running full speed without interruption.
This one over here on,
Yeah.
cog 0 in this case. I see. Yeah, so that's really helpful if you have an application that's doing stuff off screen. Let's say with motors, for example, you want to run at full speed and then potentially stop at some point. You would have to have another cog that's also exercising debug, just so that it's awake to receive the your command from the PC where you're clicking this break button to put a halt up to that particular cog. So if I did this, if I clicked break here and break here, then
you could maroon the whole thing.
Yeah. Wait a second. Would it be like this? There we go.
Yeah, now they're both.
Now I can't do anything because both cogs are running full speed and not listening to my inputs from the computer.
Right. And see the message down there at the bottom of the one on the right? To force an async break in this cog, another cog must be idling in its own debugger. So none of them are idling now. So you can't, that's okay. So you just re-download and start over.
Yeah, download again and start again. So what happens here, Chip, if right now there's only one cog that's currently active? I should be able to click this and,
Yeah, you can
oh,
click
there
it
it goes. Yeah,
because the other cog was running too.
or it was about to.
Yeah, oh
It was
yeah,
about to be launched. Did you see what I did
yeah.
there? So download, I'm gonna run at full speed. This is our right click. Oh wait, no, left click. And almost immediately, I mean, immediate in human time,
Yeah,
the other cog started up because it was,
and now it can free the first one.
yeah, and now I can free the first one. Nice.
I think that's pretty clear.
Does anybody have any questions?
I have a
Jeff.
comment. Oh, go ahead.
I was
You're
just
welcome.
thinking, Jeff.
By the way, this happens to me once in a while. I was able to get it to happen a lot on a virtual machine, but if I'm running something like, here, let me get this going again. Just do it the way I did before. On occasion, something happens in the computer that interrupts communication from the propeller, and they basically both sides lose touch with each other, and you'll see an error message that like communication debug was halted because communication was lost. Please let me know if that's happening to you. I've been able to cause it to happen on a virtual machine quite frequently, and on my host machine that you're seeing here, it happens on occasion, but usually only when I'm running Zoom, which is what I'm doing right now. I haven't been able to figure it out because I've done things where I've artificially taxed all the processors on my machine where they're all sitting at 100%, and I was still able to debug. But if I do something like run Zoom, once in a while, it'll just lose some data somewhere. The solution to that, I mean, there's a workaround. You just re-download again. Although I'm sure if it was happening frequently on somebody's machine, it would be at the worst time when they're just about to find that bug in their code. And so I want to know about that because we need to know if it's happening in the field or if it's really just happening under our kind of contrived conditions.
Hey, Jeff, did you, someone noticed a bug in the rotate XY, pole XY, and XY pole instructions?
Yes.
So I didn't put a pound sign in front of a variable I was doing a compare with to resolve which instruction we were executing so I could do one of 3 different things. So did you put the pound sign in there and then recompile everything and put it in the latest tool?
No, I did not. I didn't have time to do that.
Okay, we'll do that soon because I fixed it on my tools. It was just like a silly bug. Anyway, okay, we need to get that in there. So right now, those 3 instructions, ROTX, ROTXY, pole XY, and XY pole are probably not working right. One of them certainly not working.
Okay, so can we move on to the next item then?
Yes.
Thank you very much, Jeff.
You're welcome. Thanks
All
for watching.
We had a few more items added to the agenda while you're talking. So what we'll do now, we will actually have Kevin show off Kevin Bot 3 for a few minutes. This will be our intermission. Then we'll go to Brian Holdsworth to talk about Linux. But before we do that, Ari wants me to tell you all that we have 187 P2 edges in stock that have the 19.2 megahertz oscillator, which work fine if you make a change in your code directive. And those are available in lots of 10 for $55.30 each. And we don't have them in our store. We pulled them out of inventory. So if you want to buy them, what you can do is message Ari. And I'm putting his email into the chat right now. So again, they're $55.30 each, and you have to buy them in groups of 10. So here's Ari's email.
I just did.
Thanks, Ari. Did I get that right?
Yeah, somehow we ordered 20 megahertz parts and we got 19.2 meg and soldered them on. And now that they're on there, we really can't get them off because it's too difficult to rework those tiny little boards with those massive ground planes.
Okay, so Kevin, want to show us how you are with Kevin Bot 3?
Yeah, I'm gonna show Kevin Bot 3. So this is my robot I'm working on right now. And I'm using the P2 a lot in it for a lot of the functions. So let me bring the camera. So here it is.
Wow.
And I've got a remote for it here. It's all touchscreen. So it's using a Raspberry Pi for the artificial intelligence and other stuff, and the P2 is controlling all the hardware on it.
I see some HB25s.
And one of the screens broke for the highs, so it's all colors all wrong right now, but we get that fixed pretty soon.
That's what the cameras are seeing on the screens.
No, those are just for looks. They're not gonna do anything.
Oh, they could be like eyes.
Yeah. My camera's having a hard time focusing on them, but they're moving around.
That's pretty clear. It's hard to focus a well, it's hard to make a screen look good on a camera because the pixels bloom too much. In fact, you know, last time we spoke, someone said get a neutral. Look at this. I got a variable neutral density filter, and now I can take good pictures and video of screens without the excessive bloom.
That could definitely help.
Yeah, it was like 39 bucks from Amazon. It came in this box. It's a nano. Works great.
What is Kevin Bot 3 doing?
Well, right now, so it has 2 voices now. Kevin Bot 2 only had 1, so there's the first
Hello.
one.
Hello.
And the second one.
Hello.
I'm using an XB for the communication with the remote and the robot.
Nice work, Kevin.
Mm-hmm.
Yeah, thank you.
Yeah,
Yeah.
good job.
The eyes can change colors. Hey, this change the background here. That's much better on the video.
So you're going to build this up with a robot looking physique next? Looks like you're in the prototype stage, right?
Yeah, right now this is a prototype, but I'm gonna get a mostly aluminum frame with aluminum extrusions to make a frame and panels on the sides.
Basically, you're making an R2D2.
That's a lot of stuff.
Is your goal to make it autonomous or manually controlled, or kind of both?
It'll kind of be both. Right now, I'm just working on manually controlled because it's really hard to work on any of this before I have the body built. But it'll eventually have that with some sort of artificial intelligence. And the remote.
Your
I made all
remote,
this-
Kevin?
Now the remote's the Raspberry Pi,
Ah,
and I'm using the official touchscreen with a custom-made GUI. And change the backlight brightness. Let's see. This is better for the video. There. It's got different themes you can use on the remote. Remote's got a lot of different functions, and it can make new software for it by plugging in a USB drive, and it's got a utility on there to copy over the new code.
Very nice. Any comments, questions for Kevin here? Okay, so Kevin, I don't want to muddy your progress, but when you're ready to switch over to the brushless motor control system, we're ready to send you that hardware.
Yeah, I'm not quite ready for that just yet because I gotta get the software working, but that would definitely be great in the future.
Good. Yeah, you know, the offer stands, and at the right time, I'll let you decide that. We'll get that stuff packaged up.
Kevin, what do you want the AI to do?
I'm not quite sure yet. I gotta have all the body built before I can do anything like that. Because I don't know what I'll be able to do.
Are you gonna have voice control?
Possibly. I've been working on that with CavinBot 2 before, and I'm probably gonna have something similar on here.
It'd be interesting if you can have object identification. It could say hello person or hello dog.
Yeah. That'd be really cool.
Interesting.
You have a pet?
Yeah, meow meow.
You could have it, you know, scratch the cat or throw a ball for the dog or something. Play with your animals.
We'd probably be able to do that, but that'd be great. Because meow meow always needs to be entertained.
Actually, for cats, they love laser pointers. Hook a laser pointer up to a motion control device, and you could have your robot tease the cat with a laser pointer.
Chris, I got from Amazon this like dual laser thing with this light show as this little box, and cat went nuts. It was like putting big patterns all over the floor and the wall, and the cat was going ballistic.
Yeah, that might be something to do later.
Yeah, well, as we know, all this takes a whole lifetime, so you're going to be busy.
Yeah, I would be showing the camera streaming from the robot to the remote, but I'm using the camera right now. But it can stream the camera over to the remote.
Well, we all encourage you to keep going and bring back future iterations for us.
Yeah, I'll keep working on it.
Awesome. Well, Brian, you ready to talk about Linux?
I'm always happy to talk about Linux.
All right, all you.
All right, great. Thank you. Let me share my screen here real quick.
And just while Brian sets up, we'll also have Eric Smith at some point talk about FlexProp updates, and Stephen Morocco with the VS Code Propeller 1.2 interaction. So I don't know what order we'll do those in, but they're out there as well.
Okay. Yes, thank you, Ken, for granting me a slot today. I'm happy to have a chance to talk about what I've been working on a couple months, I guess, since about early November. Hopefully you're seeing my screen with right now a terminal window and just a GitHub page.
Yeah,
I did just, go ahead. Working good?
Yep, looks good.
Okay, great. So the website's just showing the GitHub page, which I also just sent in the chat message. And the very first line of the README kind of says exactly what this is. It's a Linux multi-tool for Propeller 2 development, and it's based off Peanut for Windows. So it's actually two repositories. This is the client piece. It's a Linux command line program that does via the command line the things that Peanut does on Windows within IDE. So it's minus the IDE plus a command line. And then it's actually built from a dependent repository, which is called P2Com. Down at the bottom, if you related projects, there's a link to that one too. And P2Com is simply a port of CHIP's compiler to a modern Linux assembler known as FASM or flat assembler. It's actually open source multi-platform assembler for x86 and x64. So if you actually want to build this thing, which I'm going to demo because it just takes a few minutes to demo it on Linux, you would clone those two repositories, which you can see I already got the two directories here in my window, P2Com and PMUT. And so to build the thing, you would start by going into the P2Com repository, and very similar to what CHIPS is set up in the Windows build is, there's a shell script, and you run that, and it cheats a little bit by using the actual the current Peanut v37 binary as a bootstrap to build all the spin2 interpreter, spin2 debugger.
Oh, I actually solved this exact problem. I have solved this exact problem with my part of the thing. You can actually just build it without the interpreter first, and then use that as a to bootstrap itself.
I have a kind of a to-do list actually to build a set of an automated test suite.
I have gotten this working before.
Yeah, and there's also there's P2asm and there's FlexSpin. There's lots of assemblers for Linux, I think.
Hey, Brian, I didn't understand. So you said that you're using some kind of like assembler, but to assemble the x86, like the 386 compiler code that goes into Peanut. Is that what you meant? I think Brian might have gotten disconnected or something. Brian, are you still there?
We're not hearing your audio, Brian.
Yeah, Brian, you seem to, we can't hear you talk at all.
He should be, looks like he got muted somehow. Oh, now he's back. I think, Brian, we could hear you.
Still can't hear him.
Say
I'm not
something,
hearing.
Brian.
I think he got disconnected. He might be trying to reconnect.
Well, his screen is still, the cursor's still blinking. Well, I'll just quit now. Maybe he's coming back.
We could still see his video and his lips moving.
The audio's dead.
Yeah.
But Chip, I might be able to help with that a little bit. You're asking about an assembler, a Linux assembler for 386 code?
Yeah, I wasn't sure what he did for the assembler portion. I didn't understand. Did you?
Well, yeah, he's using an assembler called FASM.
Okay, so it just takes the same code that I wrote and just assembles it for his own project rather than use Turbo Assembler.
I expect there's probably a few syntax changes and things that he may have had to make, but
yeah, I can chime in there, Chip. FASM is an Polish guy, Thomas, and he is writing on that thing since 10 years. It's a macro assembler which usually uses x86, but you can use it for other stuff also. It's a very, very neat assembler with a very, very, very neat macro language around it.
Okay.
And you should take a look at it. Original, it was that's the name, flat assembler. It was made for kind of a single block assembly, but later on learned a lot. But flat assembler was
testing.
Oh,
there you are. You're back.
Welcome back.
Testing.
Back.
Can you hear us?
I
can hear you, and I'm going to reshare my screen.
Okay, let's help Brian. Where did he drop off?
I was attempting to.
You dropped off again, Brian. We heard we were attempting to, and then nothing else.
whatever that is what is causing probably the microphone to go out.
His computer's censoring him.
Yes, I didn't think Linux would do that.
Normally it doesn't.
Yeah, see Linux again.
Well, what we can do is we can let Brian reboot, restart, mess with his settings, and we can come back to this unless you guys want to continue to guide what he's talking about and guess. So Brian, it seems like you could probably hear us. So what we'll do is we'll come back to you and we'll talk with Eric. Eric, do you want to talk about FlexProp?
Sure, I can do that if I can share my screen.
Go right at it.
Let me make sure I get the right desktop.
I'll start messaging Brian as well to get him back.
Maybe suggest
can
he can use a phone to dial in for audio.
Yeah, that's a good idea.
Sorry, Eric, go ahead.
No, I was just saying using a phone to dial in is a good idea. Yeah. So can everyone see my screen okay?
Yes.
Yep. Okay. So this is the new version of FlexProp. I mean, I make new releases, monthly, so it's not a huge change. But I wanted to show this new feature of calling C from spin. So I've got an object called libc that includes the C library. And as you can see, just the spin2 just can call like C functions like printf and sleep. And if I run that, you can see it's printing and sleeping for a second in between each one. Now, this is something I wanted to ask Chip about. The end of the loop, the value of I is 5. So repeat I from 1 to 5. But of course, in spin 1.
Okay, this highly controversial topic. So I just changed it back in what's going to be V38 so that it is outside of your initial, 1 to 5. In this case, it'll wind up being 6.
So like this one that I compiled as spin 1.
Yes, it's going to be that way. We had put it the other way so that it never left the bound because some teacher wanted that, and so I just did it. But then it caused a lot of trouble for people because you can't detect if the loop completed or not. If you have like a conditional quit, you can't compare it. Okay, so I put it back because it had even like complicated my own code because I had to set separate flags within loops to be able to detect if I had gotten through the loop or not.
Oh yeah. I mean, I had to implement that in FlexSpin, and
I'm sorry,
it, but it took it took a while to get it. Okay, well, I can undo all that stuff soon, I guess.
Yeah, I'm sorry about all that.
Okay, no problem. All right, so that was one question I had. The other thing I wanted to mention, I had a proposal on the forums, but no one seemed interested in it, but I just wanted to show it. That
I didn't look at the forums for a while because I was just not wanting to get sidetracked.
That's totally fair. So this is called an anonymous object. I put an underscore here instead of a name. So before I had a C, and I had c.printf. Now, because there's an underscore there, which is what we use for assignment when you don't want to do anything, I can take the c dot off of these and it still runs the same. I needed that for something I was doing internally, but I don't know if people generally want it or not. It does mean, you can sort of extend the spin language in a sense, because now you can just write like sleep.
Interesting. So that's like a way to extend the language, basically. So what are the publics in the pub methods in that object become keywords?
Right, basically. Yeah.
Yeah. That's
at least within this file.
Right.
I imagine that would be limited to just one library that you include, right? You couldn't.
Well, in FlexSpin it isn't, but I'd be perfectly I think it's perfectly reasonable to say you could only have one.
It could be.
So in FlexProp, you're just munging up, you're just taking a union of all the namespaces.
Yeah, basically. It's the same code. I already had the code for C because C has anonymous structs.
Right.
So I just reused that code for.
What happens if you have a conflict between
You should get an error, but I'm not sure you actually do at this point. It's probably just the last one declared that gets.
that'd be worth checking.
Yeah,
Be
yeah,
a great warning to have.
that's an interesting idea.
It would seem like it would get very confusing as to know which thing's coming out of what library or what object.
Right.
Well, that is the downside. So if, you know, and maybe it's not a good idea to use it much. The reason I did it is because this libc object is actually written in C, but I wanted to include all of its methods. Is it going to let me open it? Yeah, I wanted to include all of its methods. So this is using a different syntax. Instead of an underscore, I used %anonymous, but
I have a short question for you, Eric. Is it basically possible or not to use that libc object from Propeller tool?
From Propeller tool? No, it's C code. It's implemented in C. It's
but
pulling
that
in libc.m.
Shouldn't that be assembly then?
Someday I would like to provide a way to turn a FlexSpin object into assembly code that you can use in Propeller tool, but that is not working yet.
Oh, okay. That would be neat.
Yes.
Because I like a lot of that stuff you did with that file system. I finally had time to program again. And I really like your FlexSpin extensions. Starting with those default parameters, like you use in printf.
Well, actually, this printf is the C printf, so it's using.
Yeah, but no, I'm talking about.
But in the spin methods.
I'm begging Chip to implement that in Proptool, that you can use that. This parameter can be left empty and is 0, or is some constant value, whatever.
I'll show. I can bring that up.
Yeah. It's so neat.
Yeah, like here, this decimal unsigned value, digits equal 0.
Yeah.
So if you just call it with one parameter, it automatically fills a 0 in the second parameter.
And the best example is that printf thing you have there, because it has lots of parameters and they're optional.
Yeah, like here.
That is the best example. Chip, look at it. I mean, that would be so neat. If you leave them off in order, you have to leave them off in order. You know, the last one you can leave. You know.
Wait, if you leave what off?
If you
can call this like printf. You know, you can say printf. Well, it spins. So I have to say @hello 1, and that gets expanded to printf. Hello 1, and then it fills in
0, 0, 0.
and is 1, but then it'll, because it's missing these parameters, it just fills in
0, 0, 0.
Oh, okay. So
it's a way to make optional parameters.
Yeah.
Okay. Okay. You're just talking about having default values for parameters that may not be expressed.
That's right.
Yes.
Yeah,
Okay.
if you
All
don't
right.
provide the parameter, it just fills in the default.
Yes.
Python has that too.
Yeah, boy, string. You know, the trouble with the way that my compiler handles string is it's actually a whole bunch of comma separated values.
Oh yeah, I wouldn't necessarily suggest it for this string thing, but I mean the integer ones you could certainly.
Yeah, well, if you do it, actually no, if you do an @ string, it'll just send a single pointer, like a single memory pointer.
Right,
which would be
right.
sufficient.
That's what I wrote the at string here.
Oh, okay, I didn't see it. It's so tiny
Oh,
on
sorry.
my screen.
Yeah, I should probably change.
No, it's okay. I see now. Yes, that would be great. Default parameters would be very useful.
And the compiler can do it. I mean, it's just in the compile time.
And
I
you know
mean, now
what?
when we're always talking about language extensions, can I barge in once again with some stupid
Yes.
nonsense? Because what would be really useful now that we have these constant overrides is if you could do conditional assembly, because that's the main thing that's really missing, and that's kind of what the main driver behind the whole if-def thing. But I think there's a much cleaner way of doing it that doesn't involve the text replacement stuff, which is just allow an if, probably with an end, so it's not because it's not indentation sensitive, just allow an if statement in like the dat section or inline ASM. And this is evaluated at compile time, so you give it like a constant expression. And if it's non-zero, the block gets assembled, and if it's not, if it is 0, the block does not get assembled.
I see we're throwing a whole bunch of things at poor Chip.
Well,
Sorry, Chip.
hey, an idea about this, you know, what if the default values were always 0? That solves a whole lot of troubles. I mean,
But that creates like a million troubles. You shouldn't, it's kind of bad if you can use the variable and like you typo it and then you wonder why isn't it working. But
right.
Yeah, I think
That's
it's nice
bad.
to have an explicit. And also there are times like with this hex method here, I don't know if you can see this well. The default is to print 8 digits.
Right. Yeah, what you'd have to do otherwise is like if 0 then equals 8.
Yeah.
One way you can get, like, the idea of defaulting to 0 is good, and you know, a number of modern languages are doing that now, like Go and Rust do that. One way you can get around the idea of a typo invisibly making your code not work is forcing like a let or a var, or you know, some specific way when you're declaring the variable for the first time, and that if you use a variable without using one of those, now you'd get an unknown variable error.
We're actually talking about parameters to the function here, though. So I think the typo would be leaving off a parameter that you meant to include, or that doesn't default sensibly.
Why can't we just set the default parameter in the procedure? Like in Python.
Yeah, I think that's what Chip's suggesting. So if you just call hex with one parameter, digits would be set to 0, and then you test for it.
I mean, it already does that. All I would have to, well, okay, this is lazy, but all I would have to do is not care that the requisite number of parameters were expressed, because I'm going to automatically fill those in with zeros anyway.
Yeah, it's kind of nice to be able to have both kinds of functions, though, right? The ones
Right.
where you have optional parameters, but some functions you really do want all the parameters to be provided.
Agreed. Agreed.
Then you just don't
So
set the default parameter in the function.
And
Well,
there's,
but you want the caller to throw an error if you don't provide enough parameters.
right.
So there
Right.
needs to be a syntactic way to distinguish. I
Between,
mean, you could just only allow, you know, equals 0 maybe to say that it's allowed to default.
well, anytime you have an equals, it would be a default, wouldn't it?
Well, that's
Yeah,
what FlexSpin
yes.
does, but what Chip's proposing is that you would only allow equals 0.
But why limit it like that? What if
Yeah.
Well,
Because
if
it's
saying-
easy to implement.
Reuse existing code.
Yeah.
Well, also, I mean, you get
I don't-
to exploit the fact that now you can just like clear a memory with 0 without ever having to go, oh, okay, what's the first element value? Put that in. What's the second element value? Put that in. It just makes it kind of a one size fits all.
But Chip, I think the issue is you're going to have a stronger, more useful language the closer you get to your parallel syntax. And what I mean by that is Python is extremely close to what you're doing. If I'm using a lot of Python, which we do on the Raspberry Pi, and I'm doing a lot of spin, which I do when I'm paired with a P2 with a Pi, I'd rather have the languages be much closer together. So limiting my assignment to 0 is going to cause me grief as I'm thinking in the two domains constantly.
Yeah, and there's a lot of use cases for having a non-zero default.
Yeah.
I mean, I use that in Delphi a lot.
Yeah, I mean,
To
we can see them here, right? For hex, you want 8 digits. For binary, you want 32 digits.
right.
For decimal.
Yeah, 0 is not appropriate in those cases. Right.
Are you guys saying default for the compiler or default for the function? Like
For
in
the function.
Python?
For the
So, yeah.
function, each function could have its own default values for each parameter. Like
Pythonize it.
like I'm showing here on the screen, right? Hex, you always have to pass a val, so it needs at least one parameter. But the second parameter, if it's missing, it fills in an 8. Or bin, you always have to pass a value, but if the second parameter is missing, it fills in 32.
Okay, well, it can certainly be done. I just got to figure how to make that very. I mean, there's different ways you could do it. You could have the compiler just stuff the values in. That's the easiest way to do it, right?
Exactly.
Yeah, that's exactly what it does. When it checks, when FlexSpin is checking the parameter lists to see if there's enough parameters, if it finds there aren't enough parameters, it then goes back to the function definition and sees if there are defaults to fill in.
Yeah.
And if there aren't, then it throws an error.
You got things here like especially but that printf thing, it's a perfect example. You can have multiple variables in your string. Johnny Mac did that also, but he has a term.
Yeah, well, that's
with 1,
that's
with
kind
2, with 3, with 4, with 5.
Yeah, that's a slightly more extreme example, but so these functions that are on screen just have 1 or 2 parameters, but some functions might have 1 to 8 parameters.
That's called variables.
Well, but that's a whole other.
Why you missed out in your printf? You're missing the %b for binary.
How hard would this be to implement in the compiler?
Serial object out of your.
Well, it's easy. All you do is just have the compiler see if they're shy on parameters and go in and look at what the default value should be and just assemble those constants.
Correct.
Yep. Yeah, and FlexSpin only allows constants, and I think that's a reasonable restriction.
One other thing, Chip, to note is that if there is a default parameter in the function definition, that the next parameter, if there is any, also has to have a default.
Yeah.
Correct.
Yeah, you force it so that all the default, if there are any defaults, they have to be the trailing parameters.
Right. Otherwise, you don't have flexibility.
Right.
Right. Yeah, you can't tell which ones go where.
I think it's mainly a compiler thing. You have a compiler. It's ambiguous.
It's purely a compiler.
Otherwise,
Actually, it's not ambiguous if you have an optional parameter in the middle. It's just obnoxious. You can actually do that in Ruby with basically exactly the same syntax. But it's kind of obnoxious because, it's just don't do that. Never.
Yeah, then you'd have to have comma.
I don't think we need to support it.
Yeah, in languages where there are named parameters, that's a different issue.
Right.
I mean, named parameters, good.
Okay.
I mean, then you have,
but I mean, the positional ones, you can make it happen. It's just bad. So.
It's a bad idea.
We can pick this up again, but Brian, it says he's back now.
Yeah, great.
Okay, well, why don't we go back to Brian then? Oh,
yeah, but we can talk more about this.
Hold it.
Yeah.
Hi, yes, I hope I'm back with audio.
I had one last thought, but we can discuss it after. Let's go to Brian.
Yeah. Cool.
Okay. So yeah, the snafu seemed to be my webcam stopped doing audio, but kept doing video. So let me just talk a couple minutes before I switch into the screen sharing, at the risk of that might restart the chaos. So right before I started, I did, I believe, chat a GitHub link to everyone, which is probably the most important thing that I can offer you today if it turns out you're at all interested in PMUT, a Linux port of Peanut, a command line tool. And if you go to that GitHub site, basically everything I'm going to talk about is there, including a link to a screencast on YouTube that's going to show you PMUT in operation, which is really the kind of the more important piece than the how do you build it on Linux. Probably for a long time, maybe forever, I'll be the only one doing that. So anyway, let me try to share my screen again, and I'm going to be farther into what's most worth seeing here. And maybe now you see a bunch of windows and something familiar looking.
Yeah.
Okay, so yeah, hopefully what you're seeing is a somewhat slower than usual because of Zoom lag
Right.
version of one of Chip's debug demos. So this is running on Linux. And if you look to the left to the command line window, what you're going to see is I skipped over the boring part of building the PMUT executable. It's a Pascal program. It's Chip's Pascal peanut code ported to Free Pascal compiler / Lazarus, which are open source multi-platform tools. And so I've built my binary using that. And you can see I've done just PMUT by itself, and you see a usage message there. And it shows you the things it can do. Well, it can do what Peanut does for a Windows user. You can build your project, load your project, flash your project, or debug your project, and more. And it's cumulative. So if I just set my project to, in this case, I've set it to, if you look at source.top right here, I've set it to the debug plot sprites. And then I've done the command pmut debug. And it's built it, it's loaded it, and it's obviously started the debugger and showing it off. So I hope that makes perfect sense to everybody that uses Peanut on Windows, and which is exactly what I wanted. I wanted a command line Peanut, but not on Windows, on Linux and native, and with Chip's great compiler and easy to build it using FASM and other Linux tools. And so that's what I
So Brian, you used Lazarus to compile all that what is it, Pascal code. And did you have, was the existing command line, like, you know, parameter set, was that sufficient for what you did, or did you have to augment it in any way?
So what I did was try to make it sensible, at least in my world of how I think about project settings on Linux projects. I actually have this INI file. And right now it just has, you know, source top, source libs, and what COM device you're using for loading and debugging. And so, yeah, I basically made it an INI file, and then the pmut set command, pmut set, is really just a front end to show you your current project settings, and you can change them. So let's do that now. Set the top to a different, very famous chip debugger program, so HubRAM, right? So now if I do, for example, pmut build, it won't debug anything. You know, it's gonna just compile that and create your bin file. So the next thing I want to show is actually what you can do with this rapid iteration feature. And this is it's something that works very nicely, at least for me, on Linux with my editor of choice for my P2 code, which is Visual Studio Code here. So you can see I've opened up Visual Studio Code, and I've opened up the debug plot HubRAM source code. And I'm going to use a slightly different variation of pmut debug. It's called pmut watch. And so when I run this command, it does what pmut debug does. It starts up and shows the debugger output and shows it running. But what's a little nice here is that if I go into Visual Studio Code and I start making some changes, so I change HubRAM interface to HubRAM access, for example, and I just save my code. So pmut will pick that up and do all the things to rebuild, reload, relaunch, restart the debugger.
That's awesome.
Window. Yeah, it works really well if you're trying to rapidly prototype.
Yeah, so you look for the file change, and then you just rerun the script to make it happen.
Right. It watches the file system for all the dependent spin2 files, and if one of them changes, it just does all the things.
Did you? That's awesome. Did you have to modify much of the Pascal to get it to go through Lazarus okay?
I feel like I've modified your code very little, and I base this on the fact that I did everything with v36, and then you updated sometime a few weeks back to V37. And so I got a first dry run of, well, let's update PMUT to V37. And it took me an hour because the merge was pretty brain dead simple.
Okay, so you do like get diff to see what I change from version to version, so you know if there's anything you need to address.
Yeah, exactly. It's
Is it just me, or is the rendering on the circles a bit crusty?
Probably it doesn't anti-alias through the graphics calls, CHIP's graphics calls, maybe as nicely as it does on Windows. I would agree that's probably.
Well, I wonder, I'm computing pixel value, so it's computing 8-bit RG and B for every pixel, so it seems it should be exactly the same.
Yeah, I mean, it could be a zoom artifact too. I've never really squinted too hard at it because, you know.
Yeah, it could totally be a zoom thing. I mean, when you look at that on your screen, Brian, are those edges of the circle smooth enough that you can't really see pixels?
They look pretty smooth unless I squint, and then yeah, it's
okay.
it's
So
I'd have to do side by side, but yeah.
The anti-aliasing works then. It's just on this zoom thing, it's compressing down to a smaller color set.
So for me, what it looks like, each of the cogs has a dark outline that looks very smooth, but the center fill doesn't go all the way to the inside ring of that outline.
That's where some dither pixels were that were low in population, so it probably just said we don't need them.
No, it isn't color reducing. If it was color reducing the desktop, then that'd be a lot more noticeable.
It has to look good on Brian's side. I think this is just a zoom thing because we're computing every single RG and B for every pixel in that display, and there's no way that, you know, that could get screwed up.
Well,
I don't know.
I can actually look at pretty much this exact desktop display in the screencast I was mentioning, you know, that's linked from the GitHub page, and maybe that side-by-side comparison will reveal something. So I'll take a look at that. I did want to show, like, if you guys are ready to move on, just So, you know, if we escape to exit out of this, and we're kind of done with Visual Studio Code, and we're kind of done with Lazarus, where the project is, you know, you just do Shift F9. I mean, it's really just like Delphi, and you know, it rebuilds. And, you know, quite simple to make changes and test them out. Well, if you love Delphi, you'll love Lazarus.
Yeah, well, we should move over. You know, this is great because I wouldn't want it to be like a burden for you, because I always were, you know, fixing things and making tweaks and improvements. And if it's not much trouble on your end, that's better because it's going to be easier for you to.
So it is not much trouble. I mean, especially when you change the compiler side stuff, because the FASM, the port from TASM to FASM, I got down to a pretty minimal, you know, there's a sed script that changes all the syntactical things that need to be changed. And then the rest is macros. And, you know, FASM is great at macros, just like TASM has always been great at macros. So it's not much change really. What I was going to show next is, you know, like the debugger single step thing, which we really just saw in the Windows environments. And maybe this will show something about anti-aliasing too, anti-aliasing as well. But, you know, you have the same ability to pop open the debugger window, just like Proptool and Peanut have had. So awesome. That's nice if you're a Linux user like me.
It's huge.
And then, so if we exit out of that, you know, one other thing I would want to show is it's a true multi-tool, just as Peanut and Proptool are. It's just command line driven. So if you want to do something like a load of a particular file, you don't always have to use the top file. The top file is the automatic thing from the settings. But if you just want to do something that's in your path, like this VGA text demo, and you like the load feature, the way it works today in Windows, and you do that, you know, you kind of get a pretty similar user experience. It builds and loads, and you get a hubram usage window that's, like I said, straight out of Peanut. Same.
That's awesome. Hey, can you show an example of like what you had to change in the Delphi code to make it work?
I would actually, it would be my honor, Chip, to send you a detailed description of what I changed if you're interested in that. And you can digest at your leisure, and we can correspond. And I'd be really happy to share everything I learned about Delphi versus Lazarus as I went through the process.
Okay, yeah, maybe we can talk about that sometime. I'm just kind of wondering about, you know, how much and what kinds of things you had to tweak to get it to work.
Absolutely. I mean, sure.
No need to talk about it now if you've got more stuff you want to show.
Not so much. It's just that I've got a hard stop myself in about 5 minutes. So
Okay.
Because of I apologize for the delay earlier for the
That's fine.
food, but I actually do need to go, and I just want to reiterate to everyone, if you saw something here that you think could be useful to you because your development system daily driver is Linux like mine, or just anything else, comments, feedback about how it works. If you take a look at the GitHub page, obviously I'll see whatever you post there. So thank you very much. Yeah, and thanks for the opportunity.
Great, Brian.
Brian, thanks. This is a really awesome thing.
Exciting to see.
Yeah.
That's
That's
great,
good.
Brian. Thank you.
Yeah, you'll see it in the P2 newsletter this week too.
Great. All right. Well, you're welcome, and thank you to you all.
Thanks, Brian.
Sometimes these amazing efforts show up that have quietly been brewing, don't they? This is one of them. Like, what? Running under Linux, that's impressive. Well, Stephen, do you want to talk about Visual Studio Code?
Sure, I could do that.
All right, thanks for waiting so long too.
Oh, no worries. No worries.
I figured you were staying around. Nothing was in order of importance here.
Yeah, no worries.
Did Eric have anything to? I
Did
think
you
we
have something
switched.
to finish up,
Yeah, I
Eric?
think he had something else that you needed to add.
We could wait. It's just I wanted to brainstorm with Chip over some things, but
Okay.
let's let Stephen go.
This will
Good.
go. Yeah, this will go quickly. Okay, I think. What the heck? Sorry, my screen's went weird. I think you're just seeing a browser page. This is the new page describing how to set up VS Code for tasks so you can run your compilers. I pointed out as the new page because Ken is going to be updating the quick byte. And what we've done at some prompting from one of the forum members, I found a way to centralize the task set so that you, in your VS Code environment on each host, you're going to edit this file once and put it in place, and then you use it across all projects. And so now you can run FlexProp or you can run Peanut interactively. And of course, the new compiler that we just saw, Peanut, will work beautifully in here to set up your command line and downloading and everything else. So watch for a quick bytes update, and this will be explainable. You no longer are putting the tasks in each project, you're putting a user tasks file, so it works for all your projects. So the only thing unique now per project is what the top level file is within that project folder. All right, so I'll get rid of that share. I'm just catching you up on we updated tasks, so look for that. The next thing I want to show you is the next major release we had was we updated, where's my window? Right here, I believe it is. I updated the VS Code extension so that we have full syntax highlighting for P1. Pardon the code, this was written 16 years ago. This is P1 code. And you can see now it's all syntax highlighting. You may be noticing this. I like to show my end lines, ULs, as characters so we can tell if they're line feeds, carriage returns, or carriage return line feed pairs. And this is the pair. In P1, you'll notice that everything's highlighting the way you'd expect it to be. Return local variables, method calls, it's all here. And it's all highlighting. So the extension now fully supports P1. Chip a while ago convinced me to have full symbol tables for PASM and for spin within the extension. And because of that, and you'll notice we have different highlighting now for global PASM labels versus local. They're slightly different colors. Can everybody see the colors okay? Yeah,
Yes, yes.
I tried to make the font larger so you can see it. And so we see even the PASM code is highlighting quite nicely. That's P1. But we wanted to go to converting to P2. If we want to port this code to P2, we get some interesting behaviors now. To start the porting, I'm going to rename it to P2. That doesn't sound too exciting. I'm going to make this terminal window going away if I can hide what's happened with my Zoom stuff here. My buttons are all hidden here. I'll make the terminal windows go away. All right, I'm going to call up the P2 file, and you'll notice it's still syntax highlighting. But now, because I said that I want you to interpret this as P2 syntax, everything that's still P1 but no longer legit in P2 is now highlighted in red. So basically your effort now is initially going to be, how do I turn the reds into not reds? And so you can see in the methods, we're just missing parentheses, right, on these, and they color correctly. Since I have, let's do that again.
Here's a good question. Does this disable when you enable the FlexPin highlighting option that you have? Because FlexPin does not care about a lot of these syntax differences. It just does it either way.
Nope. FlexPin support is not adapted for this.
That should probably just minor thing.
Yep.
Comes to mind.
My goal is not to be fully FlexPin compliant. I just did some major use cases for you, Otto, so you could have a nicer environment there. And as we find more low-hanging fruit, I'll continue to do major use case additions. But I probably won't go full support until I have a full language engine behind here. And so we'll see. So for now, back to this. You can see how I'm converting it. Let's do unlock. If I were to convert this, it says, fine, I know what that should be. And here I'm doing the same thing. You'll notice I turned on the line mode now, and so I'm not affecting the comments as I'm doing this typing. Okay, so we have a line mode and insert and overtype, so that's built into the extension. Other things, syntactical changes, right? Let's go down to here, local variables. In P2, we changed to a dot from a double colon, and so they're automatically highlighted. In P2, we don't have the par. We have a pointer A, things like this. And so things that are not legit are all highlighted. Nice. So know where to focus your changes. In the case of, we don't have a move D, so that's probably an Alt D, but has to be previous or preceding instruction to where it's modifying. And so there's all of these things now are flagged for you to draw your attention to where the work should be. The final thing that we have, of course, as you're porting will be, there will be logic changes. And so I can't highlight that for you, but I can at least tell you these are the mnemonics that aren't going to work in this processor. So go ahead and clean that stuff up, right? And clean up your labels. And so what you find yourself doing is a whole bunch of global search and replaces and gradually coloring this back to normal.
Yeah, this just takes you right. It just shows you at once how many instances are in view.
You got it. So it's excellent. So I recently wanted to port this code and make it available. And so I realized as I was porting the code how this could work. And so, you know, necessity is the mother of invention. And so necessity. And so basically I said, I know how to highlight this. And so now it's part of our Spin 2 extension. I do not have the reverse. If you're trying to go to 2 to 1, I don't support you yet. That's a capability we could add in the future. But for right now, 1 to 2, P1 to P2 is fully highlighted like this. So what do y'all think?
Very nice.
I like it.
And
That
nicely
is very
done,
nice.
Stephen.
But how, Stephen, how does it know it's going from P1 to P2? Like,
By the file type.
Well, but how does it know that your .spin2 file used to be a .spin file?
The
That's
extension,
it.
right?
It doesn't. The extension says interpret this as P2. I have a full language definition for constants, for
Okay, so
instructions and everything else. And so when I see them not matching a known syntax or a known element that should be there, then I know, hey, that's not legitimate P2.
But
doesn't
what
it go
happens
the
if
other
you
way
have a
too? If it's not legitimate spin1 code, wouldn't it also highlight or?
Legitimate spin1 will also be read if it doesn't exist. Right?
Yeah, so like if you put a see, okay, great. So
Okay.
actually you already do have the 2-to-1.
But what happens
I
if
don't
you
have
have a function
Okay,
that
Otto,
has the
hold on,
same
please.
name as a P1 built-in?
Yeah, please don't do that. There's nothing I can do about that. And so if you're going to choose to create that confusion, you're going to be affected by it. My advice is try and stay away from P1 and P2 confusing aspects like that, because it's only going to make it harder in your life in the future as you're porting code.
Yes, I just have edge cases in my head all day.
Yeah, of course, we can do that, but it's not a good practice to.
Yeah, you probably shouldn't do it. But
Correct. And so I'm there tools that make life easy. Next, you were saying?
Are there any keywords in P1 and P2 that have the same but have a different function or meaning?
I wouldn't have any way of knowing because I'm not.
Yes. They exist. In particular, the CMP sub instruction in Python does not work the same. The add s and sub s instruction with the carry flag also do not work the same. I think the behavior of repeat loops is mildly different between spin1 and spin2. I think one of them has calculated the values once, and the other one calculates them for every loop, the limit values.
Right. But you
I think
can
that's a change.
Thanks, Otto. For this extension, I am semantic and syntax aware only, nothing else. And
that covers what, 90% of it, right?
Correct. And so there are things that you still have to know about the two languages, about their behavior. All I can do is highlight the obvious things.
Until Ada writes a new program that catches everything.
There you go. Okay, so the next.
I mean, I wouldn't do that. I just use FlexPin, and there you can just put the P1 code in, and it magically comes out correctly because of the common front end magic.
Right. Anyway, to finish my thinking, that there are areas where I'd like to take the VS extension. Ada and I have talked a lot, and it's basically awakening the rest of the language, parsing capabilities. However, the way VS Code is built is it really wants a language server behind it so I can work across files. It's VS Code by nature is not stateful in terms of how it processes the files. And so the language server becomes an independent process which understands all the files in the workspace. And so once I have that, then I can do take me to the definition of. I can validate whether an object method exists in the object and highlight it as red if it doesn't exist, if it's not spelled correctly. That kind of stuff I can't do today because we're single file limited. I'm expecting in the next couple of months, maybe I'll find a way to do this. And then do this, meaning create the language server and port the whole system over to a language server environment. And then we'll get those additional features. Right now, I'm kind of pushing the edge of what I can do in a non-language server environment. You may see that I can turn on some of the inline help, the hover text. When you hover over a PASM instruction or you hover over a spin method, I should be able to give you help and description about those. I might be able to give you help about methods defined in the current file, things like that. That could be coming as well. A lot of that is dependent on the language server. And so anything that is dependent on the server, I can't do until I go to that model. Anyway, that's all I had for today. Thank you.
It's very, very impressive.
Oh yeah, I think you forgot the outline thing that you did. It now has the labels in it.
Oh yeah.
Feature.
I guess I could show you that. I'll do one more screen share. Thanks, Ada.
Best thing.
Outline mode. Let's look. What you have now is within, for global labels within a DAT section, you now get the labels showing up in both P1 and P2.
And the good thing, of course, about this is that you can now use the Control-Shift-O and just go to the label because it's in the outline.
Correct. So now we have assembly language labels in the outline. Anything that are global labels, you'll notice these local labels do not show up. And the same thing is true for Spin 2. So that's what we're talking about here. The outline has been expanded to now allow PASM global symbols. Okay. That's
Really
the end
good
again.
work, Stephen. I look forward to updating the quick bite too.
Yes.
Wow, super awesome content today, huh? A lot of tool contributions. So what should we do with our remaining time?
I got a few things to show real quick.
Okay, and we could chat until everybody's worn out. I'll leave in a little bit, Chip, and turn over host to you at 3 o'clock.
Okay, all right. Hey, I just want to go over briefly, you know, I've been working on this, all this font stuff, and let me share. Let's see, portion of screen, here we go. So you see this here, see some. So here is like how you can do a 2-bit color, because remember those fonts, how they have dithers. So you have, in this case, like 00 is pure background, and then 11 is going to be solid color A, right? And then by that would be like a 1-bit font. You have an on or off pixel, but we found that by having some dither levels in between, some intermediaries between background and the character color, you can get really nice rendering on screens. So what I did, I had this working, I showed this last week, and I'll show you how I composed my font here. I have here like 4 stroke thicknesses for my font. And then I, each of these little, like, what is a cyan or white square is an actual screen pixel. So ideally you want your font pixels to occupy those exact areas where they are going to be reduced to screen pixels. Like it's a 3-to-1 reduction on X and Y. But what happens is I can look at this. I have a little program that looks at each box and it counts up the pixels in it, right? So it figures out, should we have 100%, 67%, 33%, or 0% of our character. So these things, these curves resolve to gray pixels. So when I run my little program that reduces this down to the actual screen font, it gets this. And this is with a little bit of italicizing applied, where it leaned the character a little bit, which you couldn't design. You could not design an italicized, you know, grayscale font by hand. It would just drive you nuts. But you can do a vertical one. Anyway, what I figured was, so I had this thing working where we had these 3 levels, and then I thought, man, it'd be kind of cool to make it so that we could do like colored font, not just solid color characters, but look at this scheme here. Whoops. So here we go to 4 bits, right? Where these patterns are the same as before, right? But I've got 4 sets of 3 left. There's 12 spaces left over, right? So what I could do is have, this is singularly unique, the background color, right? There's just one pure background, but then I can have color A, you know, solid with 2 gradients. I can have color B, C, D, and E. So I get 5 colors with background. So 5 dithered colors plus background, which enables us to have really cool fonts. So check this out. We can now have, like, you know, color gradients within fonts, which
we have arrived in the 2000s.
What's that?
We have arrived in the 2000s. Like weird old games from the 2000s tend to have these gradient fonts always. For some reason they invented it at that point and became the thing.
I see. Yeah, it does. Yeah, it kind of has a period look to it, but it's different than just straight up coloring, because what you can do is you can like play a lot of games now, like with what Steven has achieved in VS Code. He has control over like boldness, italic, and color, right?
And underline and strike through and like the squiggles, you can do that, but you'd have to report an error to actually make that happen.
Okay.
But yeah, that works basically.
We could steal a color from the scheme I have here and actually do that also. We could do squiggle underlines and whatnot. But I'm thinking that when you get into all these color coding schemes, a lot of things get like very differentiated by color, to the point where there's so many colors that you can see that something's a different color, but it's maybe not totally.
What does it mean?
Yeah, what does it mean? Right. So that's the thing. But in this case, I'm thinking, because I want to eventually move the tools over to the chip, right? So I'm thinking, how can we like have more than just color? What can we do with like shape? Like I have, see here, we have, these are IEEE Explorer, those are italics, right? But then you look at like scales here and DAC, that's like reverse italic, leans the other way. And then we have like, straight up and down, like all these zeros here. So I'm thinking that it would be neat to be able to show code by a simplified color scheme, where then you get into like shape to differentiate. Like, for example, if you have, let's say all global VARs are going to be yellow, right? And you can make some cool, like, transition color if you want. And there's all kinds of funny things you can do. But what you can do then is you can make it so that, vertical means the default, which is a long. And then right italics means byte. Left italics can mean word, because that's like more unusual, right? So what you can do then is come up with very simplified color schemes that make immediate sense, but then do subtler things to differentiate types within that category. And then you can have, bold, and we have 4 degrees of bold, but really, they kind of like they're too fine to differentiate. But you can certainly tell the light from the 0 from the 3 level, right?
Oh yeah, I mean, you could do even a completely different font. Like you could make like a serif, no serif. You could have like a script font, maybe, if you're feeling fancy.
Yeah, I thought of that too, but this little font here, it's only 7 by 11 pixels for an uppercase character. It's a pretty small font, so we can fit lots on the screen. But with the dither, it looks better than just 7 by 11. But the trouble is, when you have these like low resolution fonts, you don't have a whole lot of ability to differentiate with serifs and other things. I mean, you can kind of do it, but it's limited. I went and looked at a whole bunch of fonts that are just for, monospace for coding, and characters more or less look pretty much identical. Like, there's only one way to make a, well, there are a few ways to make, say, a lowercase b or an r, but it's all kind of like,
it's kind of all the same.
It's kind of all the same, yeah, because you just don't.
So some fonts have like the little bit weird thing, like there's one font that has like the weird eye that curves to the left. Like, okay.
Yeah. So anyway, I have it here doing the all of the like parentheses and whatnot, and kind of like a silver that graduates.
Oh, what you actually want there is parentheses coloring. This is the best thing ever. They added it to Visual Studio at some point. Like globally, it works in all the languages. If I can screen share, I can like just like show it in like 4 seconds.
All right, let's see here. Let me stop sharing. So anyway, I've showed you the font. So you get the idea of usually what the kinds of things you can do. So you
Let's
can
find a file that is actually.
You can have gradients.
Interesting in there.
So let me stop sharing here. Where'd that thing go? Here we go.
There we go. It's just random Ruby code that is, for some reason, I've opened up in the FlexSpin compiler project. Let's just go into like some other file that's like interesting. This one, this is interesting. So what you can see is that each set of braces gets its own color.
Oh, I see. Yeah.
So if you have two together, if you can find one, I don't think we have it here. There we go. Like you see these. Yeah, that's just.
Yes.
Make it
Yeah,
bigger a bit.
we could do like silver, gold, and copper, by using.
Yeah, basically. Yeah. So I think this only has 3 colors anyways. But as you can see, it can, you see the yellow one, you see it matches the other yellow one.
Yeah. Yeah.
That's incredibly useful.
Yeah,
I think it only has 3 colors. You've got purple, blue, yellow, purple, blue, yellow, purple, blue, yellow. It's goes on like
right.
that
Yeah, those
color.
are the printing process colors. It's cyan, magenta, and yellow. Yeah, so we could totally do that. But anyway, I'm just thinking it would be interesting to explore like color coding where you minimize, you try to spread the differentiation out among as many domains as possible rather than rely on color so much.
I mean, fun if you're colorblind, right?
Right. Well, there's still, if you're colorblind, you still might notice the shape of the characters, like which way.
I mean, most people aren't
how they are.
completely colorblind. Like that's a myth that some people might believe is that people just see like in monochrome. That's not how it works for most people. It's just that either one of the RGB channels just doesn't exist or gets mixed in with another one. So that's how that actually works. I think for most people, you can actually discern blue and orange. If you've ever played like any computer game in like the past couple years, you'll often notice that they use blue and orange for the color scheme. It's like everywhere. And the reason it's everywhere is because it's colorblind friendly.
So people can differentiate easily. You can make, with these color gradients, you can make things look like they're super hot or they're cold. It conveys like interesting feeling.
Yeah, the gradients are actually a kind of interesting idea because now it's not just that one color, which you can have it like you can have more stuff, more variables to do funny things. So I'm not entirely sure what you'd actually use all that for, but fair enough, I guess.
Yeah. So what I did here is I just made like a color, like start from say this color and then go to this color over 5 steps. So I have all these like colors in here that are distal colors, and then down here in this code I do the blending where I see this is the background, right? It's just purely the background color, and then here's when I do the 3 shades, first color, 3 shades the second. So what I'm doing here is for the color blending, I found it's much better to use. I'm doing here the Gamma 2.0, blend where you square and then take a square root.
Yes.
So from transitioning the colors from one color to another, it's important to use the Gamma blend, but I just use the straight alpha blend right here when I'm just computing the intensities, like, against the relative to the background. That seems to work fine, but maybe it's just because I'm using a black background at the moment.
Yes, could be correct, could be incorrect, but I think the other thing is if you're using the thing where you're counting the number of high resolution pixels and a low resolution pixel to generate the font, right? There could be a thing with that, because where you put the thresholds.
Oh yeah, I played around a lot with that, and I made a discovery. I mean, I have like 4 levels, right? Background, foreground, and then 2. There's like a 33 and a 67% mix ratio. But I found that you have to set your thresholds at kind of like somewhat exponential values, because the difference between things that are dark are greater than things that are.
That's where the gamma happens. That's where the gamma happens again.
Yeah.
So if you're quantizing to your gamma corrected nonlinear intensities, then you obviously have to generate those using the, as the actual display colors. But if you're quantizing to linear intensities, then you'd have to use linear interpolated display colors.
Come on in.
The nonlinear is actually better in this case because it's more likely to have the correct results.
You want me to come back later?
Yeah, I'll be around here for a while.
I have a question.
Thanks.
Last month, you were showing the fonts through video camera, through your analog to digital converter. And I got the impression that it didn't really do it justice. Has anyone seen those fonts through the analog to digital converter other than you?
You mean through the DAC?
The
You mean what
yeah,
actually
the
appears
component
on
of VGA to HDMI.
Well, okay, you're asking like, has anyone seen the what is
Directly.
actually on the display?
Yeah, other than you.
No, it looks really good on the display. I mean, it's very hard to get, like if you put a camera on that, it really, you know, it's like you don't see the gradual blends. The cameras are sensitive to red, green, and blue when light's being shined at them. But this thing here, this helped a lot.
So I went and I got a converter. I wanted to try it out, but is there a way we can test it out to see for ourselves how it looks?
I would just have to put the code out. I mean, I could take some stuff that I've been working on and make it so that you can run it on your own machine.
Can you put it on the forum or something?
Wait, say that again?
Can you put it on the forum or something?
Yeah, of course, yeah. Now, what I'm using though is I'm using a, well, we talked about it in one of the threads, like which component to HDMI converter to get.
Yeah, I did a lot of research. I found what I think would probably work. Otherwise, I can get the one you recommend.
They're like under $20 on Amazon.
But I spent a lot more than that.
Oh, you might not have needed to. I got a couple. One of them is very small, but it's horrible because it's like they didn't put enough bypass capacitors in it, and it injects noise into my video source analog signals, which then, you know, of course, wind up being digitized and then put out through the HDMI so that you see all these little, like, you know, just noise in the screen color.
Yeah, based on the comments and the ratings of all different types of converters, there's a big difference between them.
Yeah, these
video boxes are magic. They will add noise and weird artifacts to everything, regardless of if it makes sense or not.
Yeah, these things are all using the same probably Chinese chipset to do the conversion, but I mean, they'll go so far as to like rob it of bypass capacitance to cheapen it, you know, for margin. And
that's why I didn't spend only $20. I didn't want to do that.
Yeah, well, one of them for $20 that I got sucked, and one is great.
Okay.
You know, it's funny how that is. And then the TV, of course, you know, does its own interpretation. You know, I think this TV I have, I'm out. It's a 4K TV, but I'm using it in 1080p in portrait mode. See, I'll take my camera, and you can see my screen here, right? And if let me take this filter here and just see if I can hold it in front of there. Oh, my camera won't go that far, but anyway, it's in portrait mode.
And
so what I'll share is it's gonna output in portrait mode because that's what I've got going. I mean, it's a whole nother kind of arrangement to do it in landscape mode, which is normally how stuff is put out, but for looking at lots of code, you want to see more lines than columns. So
also, the really small fonts, you probably want to be able to choose when you want to use it and when not to, because you feel like there's some characters it doesn't do justice to, but sometimes you won't care about those characters.
Yeah, I mean, let's say that I make a whole IDE that runs on the prop, right? So when you zoom in enough to your code and you see like bigger characters, well, then it gets a lot richer. You can have these like all these italicizings, and you can have these color gradients, but as you zoom out, it has to reduce it because there's just far less information that you can put into a smaller array of pixels.
Yeah, but sometimes you want to just see a lot of characters. You're just reading normal stuff. You don't need special characters.
Yeah, exactly. Yeah, because you couldn't tell anyway. But when you zoom in, it's nice that more detail would come out.
Right.
Hey, Chip, can you also provide an update on the file driver system?
Well, yeah, okay, so I'm at this point now where I've been playing with this. I think I've taken this font thing as far as I can for now, because I've kind of pushed it to its maybe practical, where there's nothing more to gain by making it any more complicated. But what I need now, okay, I have this thing I'm trying to do that involves three things. It needs fonts, it needs a file driver, and it needs keyboard and mouse support, which today means USB stuff, right? Which is way more complex than the old PS2.
I mean, the USB is a solved problem, sort of. Like the driver kind of works. You just don't think about it too hard.
You mean the one that Gary J wrote?
Yeah, and I think I did some hacks to it, and then no, first Ray did some hacks to it, then I did some hacks to it, then Macca did some hacks to it, and I think his version now supports multiple devices, kind of, sort of, maybe sometimes, if you're using a hub.
Yeah, so I need to make it. I mean, I need keyboard, mouse, and file driver. That's what...
Yeah, it can do keyboards. It could do mouse at some point, but I'm not sure if someone broke that along the way, because I don't think anyone is actually using mice.
Yeah, and keyboard is really all you need for writing code. Mouse is good for graphical things, but
Yeah, keyboard definitely worked. I used it in MicroPython.
And I've hacked like the basic gamepad support into it. That, like,
yeah,
it can.
Well, I want to get that thing ironed out. I want to be able to have an ironed out keyboard, at least, and a mouse too eventually. But where I'm trying to go, I need file driver, keyboard, and fonts, right? That's minimum, and then mouse would be nice too.
Are you going to write an editor too?
The standalone P2 development system?
That's what I want to make. Yeah, I want to make like a Noah's Ark to get off of this big situation we're soaking in all the time, and just make something that runs all kind of on its own.
So that'll include SD support so that you can trade files with other people, right?
Of course, yeah. So there's all this like stuff that needs to be built kind of all at once. Like I can't really play with the font stuff any further until I start getting some interactivity, right? Because it needs to be conversant. It's not just show something on the screen and okay, well that looks good, but I need to make it all interactive. So now I need file system and keyboard. So I'm kind of like mulling that now, like how am I going to approach that? Right now the file system, I know I just have to code it. I know it will work because the concept's all ironed out. So
that's the flash file system you're talking about.
Yeah, the flash
USD
file system. And the USD, I'm going to have to learn. I mean, it's funny that you can plug a USD thing into a computer and it will always read it, but it seems like it's a never-ending, ever-convolving like problem that we can never get fully on top of with a microcontroller, right? Am I wrong?
I mean, the SD card file system is actually like really simple, especially if you only want to like do certain things. But I think the one that FlexPin uses actually does basically everything. It can like, I'm not sure if it can move and copy stuff like directly, but it most certainly can enumerate the directory. It can use long file names, all that sort of thing. So.
Yeah, I mean, micro SD is definitely something long-term, but there is 16 megabytes on that flash. That's pretty useful. I mean, that's a lot of memory, you know. But what I want to make...
You're talking to the person who's made the 32 megabyte Edge run out of memory, so...
I know. Yeah, so you're exceptional. I'm just thinking of more pedestrian stuff, but I'd like to make it so that just the P2 without any extra memory can be a self-hosting machine, so that, you know, you could come back many years later and still pull your code out and work on it and not have any conflicts with like what's the current state of Windows or whatever you're running.
Yeah, that's certainly a worthy goal. Now, with the subject of file systems, I seem to recall that there's a conflict between the flash and the micro SD.
Oh, you mean an electrical conflict?
Yeah, I'm not a hardware guy, but
yeah, we swapped some pins around. We probably should have just done that on separate pins, but we made it so that we switched the clock and the chip select, right? Between the SD and the flash chip. So, and then SDs have further issues where, I mean, they have an issue where they get stateful and locked up, and the only way you can pull them out is by cycling their power, which needs, you know, more pins and maybe a PFET. So the whole thing is kind of, and then at our boot up, you know, we try to differentiate. Well, we see, do we have a micro SD? Do we have a flash? And so it's kind of convoluted and messy. I wouldn't, I mean, that's a whole nother thing that's going to have to be resolved, and I don't know how well we can resolve it.
So something you're saying right now, to reinterpret what you're saying, is that you're suggesting that it might be unlikely for us to have both devices fully functional on a given P2?
I don't know. I think if we can control the power to the micro SD card and give it a good reset, because it seems that you cannot fully reset it by giving it commands. Sometimes they they get into some state, and only cycling power will bring them back.
I don't think that's like, to get it into that state, you have to make that happen somehow, which that only works that only can happen if the code is somehow bad and sending it a command that it doesn't like.
Okay,
or if you reset it while it's doing something, which only really happens while you're developing code, right?
Okay. All right. So we should, in theory, then be able to have like concurrent file systems on flash and micro SD over the same 4 pins total.
It should work. Sometimes it may be an issue with what kind of SD card you have. If it's like a weird no-name off-brand one, then they sometimes just